Here we are back up at the rain barrel location, and this is just for your info. This is how the little garden is progressing. It's really not that big of one. The cucumbers are going kind of crazy over there. But in any event, this is the rain barrel now that we're going to be concerned with. We're going to talk about pressure today. It's math and science together, real world stuff. And so this is the rain barrel that we haven't messed with yet. And down here you can see I've got a garden hose connected to it. It's currently in the off position, the valve right there. Now this garden hose, let me back out here. This garden hose goes through the front yard here and down a hill, and can't really see it. We're going to lose it here in a minute, but it goes basically down this hill. You can see it down there, okay, and then it parallels the dress right along the side of the driveway and goes to the bottom of the property here where you come in, and we're going to try to determine what the pressure of this water is going to be way down there. Okay, so from the other video, you know that our rain barrel water height is basically right at where I'm pointing right here. And I have in front of me here my handy dandy trusty altimeter, barometer, compass, chronographer, etc. And so I've got it in the altimeter mode. Altimeter is measures height, altitude actually. So you can see right here basically at the start of the water level, the maximum water level here at the top, it's write this number down, 2,697 feet. Okay? You're going to determine the pressure at the bottom in pounds per square inch, PSI, based on the height difference of the water level from here at a full rain barrel down to where I want to water. So we'll go down there and take a look here in just a second. Just so you know, there's really two main components of pressure: static pressure and velocity pressure equals total pressure. So this is an equation for the real world that's used all the time by engineers and scientists and technicians, etc. It's particularly important for airplane flight, static pressure and velocity pressure, but it's also because air is a fluid, so is water. So we're gonna take this height, this feet elevation difference, and convert it into that static pressure, because the water's stationary. We're going to convert that into pounds per square inches, which is what we usually talk about over here in the U.S. anyway. Just for the heck of it, here's the front yard of our little place in the mountains here. I laid this stone pathway here. Actually got another little rain barrel here. It's the first one I put in it. Carol uses this for the plants and stuff up here at the top. And here's what our front view looks like in the mountains. Pretty cool. And normally in the fall, when the foliage is down, you can see there's a lake right between those two mountains that you can Echo Lake, which is a pretty cool place. So that's a little side note. So obviously I'm in my truck now, and there's the house at the top, if you can see it. I'm coming down the driveway, and there's the hose as it parallels the driveway here. I'll try to do just a little of this and then stop so I won't run off and have a problem. So you can see where it's running along the driveway. We installed this because we haven't had much rain, and I couldn't get my pond system to work. The dam washed out in the creek, so I had to build a new dam. I finally got it working, but we put this in just in case we needed to water down at the bottom, and without the pumping system that I put in that we usually use. Okay, so now we're down almost to the bottom of the driveway here. There's the first little building. There's my pump house, and then my shed for my tractor and stuff. And so here's the hose. It's still coming down. There's a little shed I built with my tractor in there and some miscellaneous mess. There's a riding mower in there too. So anyway, as you can see, there's the hose, and we're headed towards the front, and let's go there. Okay, so I'm down at the bottom now. Here's the first flower bed. There's not much in it. It's really a fall flower bed. There's a lot of bulbs planted in there that come up, and then there's the other one over there. Carol had a bunch of roses in there, but the weather kind of beat them up pretty bad. There's a property line. You can see the fence line, and usually right out there we have a huge garden. You can see where the plow marks are kind of located. The problem this year was right here. This little creek, okay, which is kind of hard to see, comes underneath the road there and heads this way, and is my water source for my pumping system in that pump house over there of a pond. So I had to this whole thing washed out. The builder put in a pretty crappy lightweight dam, so I brought in a bunch of big rock, small rock, medium-sized rock and everything. And right, if I can find it for you, right there's a pipe, okay? There's a pipe, and that pipe goes underground, and it goes all the way over to this pond way over there. Here's a pond. I don't know if you can see it. It's kind of hard to see, but there's a weeping willow tree in front of it. But so that water from this dam, by way of a pipe underneath the soil there, fills that pond up, and out of that pond I have a pump that pumps water to my big garden down here. So it wasn't working this year. I finally got it working, but it was too late because we didn't plant the big garden. Okay, so by the way, here's my altimeter again. It's in altimeter mode, and you can see the elevation down here at the bottom. You remember the number at the top. Write this number down. You're going to need it, because the difference in those two numbers is going to help us determine the pressure in PSI down here at the hose connection. Okay, so down here, here's the hose coming in from up top at that rain barrel. Okay, so that's a lot of water to fill up this hose. I wonder how much of that rain barrel it will take to fill it up. We'll find out in a minute. But in any event, I put in it's called a Y fitting here. It's got two valves on it. You can see these little levers right here. It's a little ball valve. It's either closed or it's open. Okay, so I'm going to close it back. I don't want to let any water out just yet. And then this side's the hose connection. So I'm going to put a pressure gauge right here, but you're not going to be able to see what the pressure is because that's what you have to calculate. So I get to see it and you don't. Ha 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 ha. So we'll open the rain barrel valve here in just a second and see how much water, see if we can get a good spray out of this thing. I suspect it's going to be pretty strong. Okay, so here's the hose down here at the bottom, and there's all the hose. Of course, it goes up the driveway, and that's the kind of I'll water her flowers while I'm standing here. She'll be happy about that. So that's the kind of pressure we're getting down here, which is just, there's no pump on this thing. It's just gravity fed, and it's all due to the static head or static pressure, hydrostatic pressure to be more exact, of that rain barrel up there. So that's pretty cool. So I'm going to turn we're still getting air out of the line. What you're hearing there is, it took about 3 minutes for the water to get from the top to the bottom because of that. We've got about 1,000 foot of hose here. So I'm going to stop it and put my pressure gauge on, but you don't get to see it.